Imagine a vast ocean where there is now only sand. Where once whales swam, now camels walk. This is the story of how some deserts over millions of years were once covered by oceans. Deserts seem timeless and unchanging, but the Earth is a planet in constant motion. Over millions of years, even the most enormous landscapes can be transformed. How can something as massive as an ocean disappear and be replaced by a dry, sandy desert? To understand this, we need to journey back in time and explore the powerful forces that shape our planet. The Earth's surface is not one solid piece. It's broken into large pieces called tectonic plates. These plates fit together like a giant jigsaw puzzle, but they are always moving, although very slowly. Over millions of years, these plates can move closer together or drift further apart. These movements are tiny compared to a human lifetime, but over many, many years, they can cause incredible changes to the Earth's surface. These movements can cause mountains to rise where oceans once existed. They can also change the shape and size of continents and oceans, redrawing the map of our planet over millions of years. When tectonic plates move apart, they can create rifts or cracks in the Earth's crust. Magma, which is molten rock from deep inside the Earth, can rise up through these cracks and erupt onto the ocean floor. These eruptions create new ocean floor and push the existing ocean floor away from the rift. Over time, this process, called seafloor spreading, can cause oceans to grow wider. Conversely, when tectonic plates collide, one plate can be forced under the other. This process is called subduction. The descending plate can then melt back into the Earth's mantle, causing the ocean floor to shrink and continents to move closer. Climate change plays a crucial role in the transformation of oceans into deserts. The Earth's climate has gone through many natural cycles of warming and cooling over millions of years. These changes can be caused by variations in the Earth's orbit, volcanic eruptions that block sunlight, or changes in ocean currents. Each of these factors can influence the amount of rainfall and evaporation in a region. When a region experiences a prolonged period of low rainfall and high evaporation, it can lead to the formation of deserts. This is because the lack of rainfall prevents plants from growing, which in turn leaves the soil exposed and vulnerable to erosion by wind. Section 5. The Sahara, once an ocean. The Sahara Desert, the largest hot desert on Earth, provides compelling evidence of the ocean-to-desert transformation. Stretching over 9 million square kilometers, it is a place of extremes, with temperatures soaring above 50 degrees Celsius during the day and plummeting to near freezing at night. But this arid expanse wasn't always a desert. Millions of years ago, this vast expanse of sand dunes and rocky plains was a shallow sea teeming with marine life. Imagine a world where the Sahara was covered by warm, shallow waters, home to a diverse array of marine creatures. Over time, geological and climatic changes transformed this ocean into the desert we see today. Scientists have discovered fossils of ancient sea creatures, including whales, sharks, and even sea turtles, in the heart of the Sahara Desert. These discoveries provide a fascinating glimpse into the region's aquatic past. The presence of these fossils in such an arid environment is a testament to the dramatic changes our planet has undergone. The fossilized remains of sea turtles, for instance, tell us that these creatures once swam in the waters that covered what is now an endless sea of sand. These fossils are like postcards from the past, telling us about a time when this now arid region was submerged beneath the waves. They offer invaluable insights into the Earth's climatic history and the processes that have shaped its surface. These fossils, along with the discovery of ancient coastlines and sedimentary rocks that only form in marine environments, paint a clear picture of the Sahara's watery past. The sedimentary rocks in particular reveal layers of history, showing how the environment transitioned from a marine habitat to the desert landscape we see today. This transformation is a powerful reminder of the dynamic nature of our planet. Section 6. Whispers from the Past. Fossils are the preserved remains of ancient plants and animals. They offer a fascinating glimpse into the distant past, revealing the secrets of life that existed millions of years ago. These remnants are like time capsules, capturing moments from eras long gone. They can be bones, teeth, shells, or even footprints left behind in sediment that later hardened into rock. Each fossil tells a story, a narrative of survival, adaptation, and sometimes extinction. The variety of fossils found can be astonishing, from the tiniest microorganisms to the largest dinosaurs. Fossils are like clues that help scientists piece together the history of life on Earth. By studying these ancient remains, researchers can reconstruct ecosystems, understand climate changes, and trace the evolution of species over millions of years. It's a meticulous process that requires patience and precision. In deserts that were once oceans, we often find marine fossils. These discoveries are particularly intriguing because they reveal how dramatically Earth's landscapes have changed over time. Imagine standing in a dry, arid desert and realizing that it was once a thriving seabed teeming with marine life. These are fossils of creatures that lived in the sea, like fish, shellfish, corals, and other marine organisms. Each fossilized creature provides a snapshot of the marine environment, offering clues about the water's temperature, depth, and the types of organisms that live there. And even giant reptiles like plesiosaurs and ichthyosaurs. These massive marine reptiles dominated the oceans during the age of the dinosaurs, and their fossils are a testament to the incredible diversity of life that once existed in our planet's oceans. Finding marine fossils in a desert is a clear indication that the area was once underwater. This transformation from ocean to desert is a powerful reminder of the dynamic nature of our planet. It also highlights the importance of fossils in understanding Earth's geological history. It's like finding a seashell in your backyard. You know it had to come from somewhere else. Such discoveries spark curiosity and wonder, encouraging us to explore and learn more about the world around us. Fossils are not just remnants of the past, they are keys to unlocking the mysteries of our planet's history. Section 7. Clues in the sand. Apart from fossils, geologists also look for other clues that tell us about a desert's watery past. These clues are often hidden in the very rocks that make up the landscape. One such clue is the presence of sedimentary rocks. These rocks are like pages in a history book, each layer telling a story of a different time period. These rocks are formed from layers of sand, mud, and the remains of living organisms that settle to the bottom of oceans, lakes, or rivers over long periods. The process of sedimentation can take millions of years, gradually building up layer upon layer. The type of sedimentary rock found in a particular area can tell us about the kind of environment that existed there in the past. For instance, the presence of certain minerals can indicate whether the area was once underwater or exposed to the air. For example, sandstone with ripple marks indicates a shallow water environment such as a beach or riverbed. These ripple marks are formed by the action of water currents or waves, leaving behind a telltale pattern in the rock. While shale with fossilized marine creatures suggests a deeper ocean setting. The presence of these fossils can provide valuable information about the types of organisms that lived in the area and the conditions they lived in. By studying the layers of sedimentary rocks, geologists can create a timeline of the environmental changes that occurred in a region over millions of years. This timeline can help us understand how the Earth's climate and landscapes have evolved, providing insights into the processes that have shaped our planet. Geologists use a variety of tools and techniques to study these rocks, including field observations, laboratory analyses, and advanced imaging technologies. Each method provides a different piece of the puzzle, helping to build a comprehensive picture of the Earth's history. The findings from these studies are not just academic, they have practical applications as well. Understanding the geological history of an area can inform everything from natural resource management to predicting future environmental changes. So the next time you find yourself in a desert, remember that the sands beneath your feet hold clues to a watery past, waiting to be uncovered by those who know where to look. Section 8. A planet in motion. The transformation of oceans into deserts is a testament to the dynamic nature of our planet. The Earth's surface is not static, it's constantly changing due to the interplay of tectonic forces, climate change, and erosion. These processes happen over vast stretches of time, often too slow for us to notice in a human lifetime, but the evidence is all around us, embedded in the rocks, the fossils, and the very landscapes we see today. Understanding these processes helps us appreciate the immense scale of geological time and the profound transformations that have shaped our planet over millions of years. Section 9. From ocean depths to desert sands. The journey from ocean depths to desert sands is a tale of constant change driven by the powerful forces that shape our planet. It's a story written in the rocks, whispered by the wind, and etched into the very fabric of our Earth. So the next time you see a desert, remember that beneath the sand lies a history as deep as the ocean itself. A history of ancient seas teeming with life that have long since vanished, leaving behind only clues in the sand and whispers from the past.